This is an ancient PC monitor, and in this video I'm going to steal the CCFL out of it. Now, what even is a CCFL? The CCFL is a cold cathode tube, and it works kind of like a CRT. But let me explain. There are two metal cylinders, one here and one here. In them there is a cathode and an anode. And what happens then is a second voltage is applied here, and the cathode, also in here, spreads electrons out, and those electrons are wandering through this glass cylinder. This glass cylinder also contains a vacuum, same as in the CRT, and a magnet field steers the electrons, so only this area is lighting up. If you turn on a lamp using this cold cathode tube, 1 voltage is applied to the cathode, and for a short amount of time a second higher voltage is applied to the anode. As I said previously, this anode fires the whole thing up. Now, why is it in an old monitor? Let me explain. Those old monitors look kind of like this. There is the case here and the glass on the front. Between there are a few layers of different material that form the screen. Those old monitors were not able to light up on their own. They needed a lamp to light up. That's where the CCFL comes in. The CCFL is positioned behind those screen layers, as you see here. And the CCFL is the thing that actually makes your screen lighting up and your picture visible. Today we do have OLED screens that are lighting up on their own, or we do have those screens that use LEDs instead of the CCFL. So as I said, that monitor is ancient. In my case, something inside these screen layers is broken, or I suppose it is the connector to those screen layers. But the CCFL is still working. Now, normally I would say let's repair it, but those monitors are often soldered SMD, which means if one solder joint breaks, you can repair it. You can repair it by using a hot air gun or something like that. But sadly, this does not work forever. The solder joint you repaired by heating it up works for the moment. But if you power this monitor up, all the components inside get warm. If you turn it off, they cool down. This is called thermal stress. And as the name suggests, it is very stressful to the components and especially the solder joints. And if one solder joint is broken, it will break again. So there is no real need for such an old monitor to get repaired. It is not forever. It could be the case that it breaks tomorrow, but it could also be the case that it works for 5 years straight. So there is no real need for it to get repaired. And now let's get to the interesting stuff. First thing you want to do is you want to loosen all these 4 screws. I broke that one, the other 3 ones are loose, so you can lift this one up. Well, before tearing everything apart, it is recommended taking a look at this circuit board. This circuit board is the actual board that supplies the CCFL with the needed voltage. And as you see over here, those 2 connectors are going to the CCFL, which makes me think that there are actually 2 CCFLs. And this is the only connector that goes into this circuit board. And we need to know which voltages are applied where. That's important because we need to find a way to power this CCFL. Black is our ground. That's important to know. I finally figured it out. If there is no signal coming into the VGA plug, the screen is turning off after 5 seconds or so. So we only have 5 seconds to measure 1 voltage. As you see, changed a little bit. I cut all these cables and pulled them back together, because now I have small metal connectors where I connect my alligator plugs. And we will start with the red wire. Now, as you see, there is a voltage, 12 volts to be exact, 11.9 to be exact. Let's turn off the screen. The voltage is 12 volt steady. Now let's get to the next alligator plug. The next one will be the blue one. This works like a signal voltage, AC, that fires that whole thing up, which makes things much heavier for me to figure out. Now let's check the green voltage. As you saw here, this is another signal voltage. It actually delivers 3.2 volts. That is interesting. The next thing I want to try is what happens if I cut off that signal voltage with 90 millivolt peak. And as you see, I cut that off. Only that 12 volt line that is active anyways, and that 3.2 volt line. Let's check what happens if we turn it on now. Yeah, I put this old smartphone down here to monitor whether the monitor is turned off or on, and I was able to see that the monitor actually switches on, which means we only need a way to supply 12 volt and 3.2 volt at the same time. Now that we know all the values of the voltages, we can actually start with the teardown. Right now I'm powering the panel by using a 12 volt power supply that normally has been used to charge a laptop, and the 3.2 voltage to control everything is applied through my lab supply. Now I already configured my laboratory supply to 3.2 volts. There you go. It is lighting up, as you see. After verifying that it works by using a lab supply and the 12 volt power supply, I quickly got a few components and soldered them together. After that I glued them on the back of the actual lamp. And now it is time to verify that everything works. But before we do that, let's take a look at the way I connected everything. The only power unit is this 12 volt plug that plugs directly into the wall. Plus 12 volt go directly to the lamp over here. Minus goes to this switch here. And there are 3 minus over on the output of the switch. They are all 3 connected together. One of them goes to the 12 volt and makes the 12 volt circle complete. One goes into this step-down converter. The step-down converter also grabs its 12 volt from the 12 volt line over here. The output minus of the step-down converter is connected to the minus of the switch, as you see on this bridge here. 3 volts are getting supplied through the lamp over here. And that's everything. Let's test it out now. Now it's time to flick the lever and see what happens. And it turns on. I did it, as you see. Both the upper one here as well as the other one down here are lighting up, which means I did it. And switching the lever makes it turning off. Great! Due to some experiments I did, I actually found out that those two foils combined made the light a whole lot brighter. So I'm just going to glue them together on all 4 sides, and after that I'm going to glue them onto the lamp. Now I need something that actually holds it in place, because now I just can use my hands and use it, but that's kinda annoying. I want this thing like a softbox to stand somewhere and shining onto a place. The next thing I want to try is building a stand for my lamp. For this I first needed to saw a wooden slat and glue it on the back of my lamp. After that I sawed 2 more or less identical slats. And it looks exactly like this. And as you see, the lamp is pretty damn bright. And it works very well for me. I put very much effort into this project, so please, if you like this video, leave a like, write a nice comment and subscribe to the channel so you don't miss any future DIY projects. Thanks for watching and have a good one.